Let's use two simple examples to understand how to write concurrent programs with actors. So the first is what I'll call a print actor. And its job is to receive messages like all actors, and there could be messages like hello, world, and we'll assume that it has a designated string exit, which will be a message for it to terminate itself. And its action is simply going to be to print the messages it receives, hello, world, and then after receiving exit it terminates, and it will not act on any more messages after that. So how do we implement this simple actor? Well, actors have state and methods that operate on the state. So what you have is a method that's typically called process, and that takes the body of the message as an argument. And in this case, the logic we want is, well, we'll first check to see if S is a special exit string. If so, we exit the actor. Else, we just print S. And that's all you need to do. Once you've created an actor and started it, it's in a reactive mode, and every time a message arrives in its mailbox, the runtime will ensure that this method process is called on that method, kind of like a callback. So one interesting question is, what about the ordering of the messages? We saw those three messages and assumed the strings would be printed in this order. And in fact, for most actor models, it is the case that if the messages come from the same sender and go to the same receiver, the print actor, their order will be preserved. This is not always true in real life. For example, if you take email and a friend sends you two emails in quick succession, and the first one just happens to have a really large attachment, and the second one is short, it is possible for the messages to be reordered. But actor systems do some extra work to make sure that from the programmer's perspective, the messages are in order if they come from the same sender and go to the same receiver. But if they were sent by different actors, so if this was sent by actor A, this was sent by actor B, this was sent by actor C, then the messages could be reordered. So it could be that process is called on world first before hello, in which case the actor will print world hello. Or it could receive the exit message first, in which case it would be it would exit. This is not a bug. This is inherent in concurrent programs, that you have this non-determinism, and the semantics is very clear based on message ordering, whether it comes from the same actor or a different actor. Let's look at another example, and that is one of pipelines. So I'll take a pipeline that processes strings, and let's say that the pipeline stage that checks if the strings are lowercase. And it acts as a filter, so it will pass all lowercase strings down, and then it will check if the strings have even length. So with this pipeline, for example, if we provided strings like uppercase ABC, DE, FGH, then the lowercase actor will read all three strings and pass forward only the lowercase strings like DE and FGH. And then the even length actor will look at these input strings and just pass forward the strings which have even length, which is DE. So let's say these actors are named X and Y. How would we implement the code for one of these actors? Well, for something like X, we'd again have a process method that takes a string, and what we want to do is check if the string is lowercase And if so, we want to send it forward. So that's very easy. There's actor Y, and you send it S. And that's it. That's all you have to do to implement the lowercase stage of this pipeline, because if the string is not lowercase, all that's happened is this actor swallowed the message and not passed it on. And if it is lowercase, it sent it on to Y. This really helps, because if you're trying to implement the same logic with threads, you'd have to worry about threads constantly checking the mailbox to see if there are incoming messages, and making sure that all that concurrency coordination is done correctly. So with these two simple examples, you should be getting an idea of the power behind the actor model by making sure that the state is local and just specifying declaratively the action to be performed on each message. You can create very complex concurrent systems, as we'll see in later lectures in this class.